Yeah, so did you guys have a look at linked list? I did not get any reply actually. All of you can hear me? Hello,
Yes,
can you
sir.
hear me?
Yes, sir.
Yes. So
Yes,
did
sir.
you read the linked list part? In fact, we got one extra day. No, yesterday I could not take a class. Did you read the linked list part? एक एक्स्ट्रा दिन मिलके भी दो तीन पैराग्राफ नहीं पढ़े. This is not fine. Now this is problem. Not for me. Problem for you only. Because we have to go ahead. No, we cannot keep spending too much time on the same thing. I am asking you to read so that when you come here and when I explain, you will understand faster. It becomes easier for you to understand. Has anybody read this part? Just quite poor, huh? Just quite poor. Hmm. I gave you reading part because I did not get time to record any lecture or anything. That's why. But is that going to be easier if I record lecture and put up videos and ask you to watch that? Will that be easier for you than reading? I thought these diagrams and all, instead of drawing, they are much neater for you, which is why I thought you should
Sir,
read this part.
recording will be better.
Recording will be better, but you should see the recording. No, आप देखेंगे नहीं तो फिर. The issue with this part, I mean data structures, this chapter is that ये जो diagram वगैरह है मुझे बनाने में time लगता है and it will not be as good as what you see here. That's why. But did you even try to read? Somebody replied. Priya replied. No. Did you even try to read this part? Can you tell me something that you did not understand or something?
सर उसमें डायग्राम्स मतलब ऐसे स्ट्रेट फॉरवर्ड नहीं समझते हैं. लाइक लास्ट टाइम भी किया था तो वो डायग्राम्स उतना जल्दी क्लिक नहीं हुआ था. उसका
अच्छा.
वर्डिंग ठीक है, मतलब वर्डिंग समझता है लेकिन वो उतना नहीं क्लियरली ऐसे क्लिक होता है. रिकॉर्डिंग में आराम से समझ जाता है क्योंकि
अच्छा.
आप उस टाइम एक्सप्रेस करते हो, मतलब एक्सप्लेन करते हो, तो फ्रॉम माय
Mhm.
पॉइंट ऑफ व्यू रिकॉर्डिंग इज बेटर.
Okay. Fine. Fine. Then we'll do that way. The recording maybe then I'll try to use the diagram from here so that I don't have to draw it again. But then I'll explain in words so that might be easier for you. Okay. So let's do that. Okay. That's okay. Okay, so we will do linked list today, but just give me 1 minute. I'll get something to write. Just give me 1 minute. By the way, is everyone here? How many people are here now? Only 16 people. Give me 2 minutes. I'll get the writing instrument with me. In that 2 minutes, or some just message people who are missing if you know something. Is everybody able to see the board right now?
Yes, sir.
Yes, sir.
So we have seen array, we have seen stack, we have seen queue, right? And linked list is actually much more general than all of these things. Okay, so right. So linked list is much more general than these things. In fact, each of these things, array, stack, queue, binary tree, each of these things will be a special case of a linked list. Okay. So let's start with general idea of what a linked list is. Okay. तो इसमें मतलब क्या है? It's a list, है ना? It's called a list. So it is a list. It's a list of elements, right? But there is a link between the elements of the list. Okay. Every element is connected to some other element. Think of it that way. Is that okay? Every element is connected to some other element. Okay. For instance, let's go back and look at some of the examples that we've seen before. For instance, in an array, okay, A is an array, okay. Which are the elements of this array? Can you tell me? These are the elements A1, A2 up to A10 in this case. These are the elements of the array. Are these elements connected to each other in any way? Can you just look at this and tell me, is there a connection between these elements? फॉर्मली टेक्निकली डेफिनेशन कुछ नहीं चाहिए, बस देख के अपने आइडिया से बताओ कि इन एलिमेंट्स में कोई कनेक्शन है क्या, A1 to A10. Just look at the way the elements have been written, A1, A2, A3 in this fashion. No, some, it's not written in some A1 इधर, A2 इधर, A3 इधर, A4 यहाँ पे, A5 यहाँ पे, ऐसे कुछ नहीं हो रहा है ना? You understand? That's
Yes,
what I am
sir.
asking for.
Yes,
So
sir.
it's not written, the elements are not here and there without any connection to each other. There is something that connects these elements. What is it? What do you see? You understand the question? Just try to tell it in your own words. It does not have to be perfect. Just try to find out what is special about this array. It's a collection of 10 elements, A1 to A10. But what is special about it? Okay, so let's ask another question. If you have to find the minimum element in an array, what will you do? Somebody, many of you know the answer.
Comparison.
What will you do? Sorry?
We compare, like we compare the numbers and then we can find the minimum.
Yeah. So we have done algorithms now for sorting and all. Now you should not say like this in words. First step क्या है, second step क्या है. Remember we did all this before. What is the first step?
Yes, sir.
Ah, what is the first step?
First we divide the array in two halves.
Okay, we do that. Okay. So which algorithm are you using? You're trying to sort, no? Suppose I only want to find the minimum. I don't even want a clever algorithm, just some very simple way. It might take too much time. That is it. If I give you just 10 numbers, A1 to A10, देख के बताने को अगर कहा कि सबसे छोटा एलिमेंट कौन सा है, what will you do?
Sir, by heap sort we can do.
Yeah, we can do by all those sorting methods, comparison, insertion sort, heap sort. I'm saying sorting will sort all the elements. I only want the minimum. I don't care about sorting only. सबसे छोटा element क्या है? That's all I want to know. Okay. Suppose I give you 10 elements and ask you what is the smallest element. What will you do? Just for finding the smallest element. People know this answer, right? I mean, we started out with this question only, and some people had answered at that time. Even before we did sorting. You will compare obviously, but you'll start from where? How will you start comparing? That's all.
अरे को 2 पार्ट्स में डिवाइड करें.
हाँ, वो फिर से सॉर्टिंग एल्गोरिथम पे जा रहे हैं आप. मुझे
सर अगर डायरेक्टली मिनिमम फाइंड आउट करना है तो हमें फिर 1 बाय 1 ही तो कंपैरिजन करना पड़ेगा ना, अगर
हाँ,
सॉर्टिंग
तो
का नहीं
वही
देखना.
पूछ रहा हूँ मैं, वही बताओ 1 बाय 1 कैसे करेंगे.
लाइक फर्स्ट एलिमेंट को विल कंपेयर विद सेकंड एलिमेंट एंड देन वी कैन स्टोर द मिनिमम नंबर. देन इन द
Okay.
सेम वे जो मिनिमम
That,
नंबर आएगा फिर थर्ड एलिमेंट से होगा.
okay. So what does it mean to say first element, second element, third element, and so on? What does it mean to say that? Do you realize ये जो A1, A2, A3 दिख रहा है, ये बॉक्स के अंदर ये नहीं लिखा होता है ना. यहाँ A1 के जगह कुछ
हाँ,
लिखा होगा.
नंबर लिखा होगा.
हाँ, नंबर लिखा होगा ना, तो A1 है, A2 है, वो तो नहीं पता है. तो what do you mean by first element, second element, third element? What does that mean? It means that there is an order in this array. Do you realize? There is an order among these boxes. The way it has been constructed, you know what is the first box. Given any box, you know what is the next box. Given any box, you know what is the previous box. You understand what I'm saying? Given any box, I know what is the next box. I know what is the previous box. I know what is the first box. I know what is the last box. You see, all of this is possible because there is an order among these boxes. These indices 1, 2, 3 up to 10, they are giving me an order among these boxes. Do you understand what I'm looking for? What I'm trying to
यस
say?
सर.
ऑर्डर है इसलिए बता पा रहे हैं ना कि अगला वाला क्या है. अगला वाला का मतलब क्या है? देयर इज सम ऑर्डर.
हाँ.
Right. So if you want to think about a linked list is just a relaxation of this idea. In linked list, you don't specify this order as 1, 2, 3 up to 10. These indices are not mentioned like this. So let's go to linked list. So before I specify, before I mention linked list in general, let's write linked list, these examples as linked lists, and then we'll see. So an array as a linked list, I'll write it as LL, okay, sometimes. Array, and I'm not making it formal, I'm just giving you an idea. Array as a linked list, it's this way. You have the first box, you have the second box. There's the first box, the second box. Now these numbers are not present. I'm just writing them down so that it's easy for us to understand. You have the third box, you have the fourth box, you have the fifth box. Okay. This I'm saying only for you to understand, but these numbers are not there. These are just 5 boxes with no order among them at present. How will you make an array out of them? It's by adding some compartments to these. So these boxes are going to contain some numbers. Right? These are the numbers to be stored in that array. So those are empty boxes for now. We will fill them with numbers later on. Okay, one second. Right. So we fill these numbers with boxes. We fill these boxes with numbers later on. But you have to make an array out of these. Do you understand when I say that at present they are just 5 boxes lying somehow? There is no order between them. 1, 2, 3, 4, 5 is the order we have to put between them. I have just written them down so that you will understand what we are doing. At present, there is no order in these boxes. Is that clear?
Yes, sir.
Yes, sir.
Okay. These are just 5 boxes. Now I'm going to connect them and give you an order. How will we do that? So every box is going to have 2 additional compartments basically. Okay. The additional compartments are going to be used as what are called pointers. Okay. So there are going to be 2 pointers for each box. And they are going to be called previous and next. Understand? Previous and next. Okay. Now, if this has to be the first box, what will be the previous? There is no previous, right? This is the first box. If this is supposed to be the first box, there's no previous. So this pointer is empty. Okay. There is no value given here. There is no arrow. There is no pointer. Nothing. This pointer is empty, and we'll denote it by this symbol, just a slash. We'll put that slash here, and this pointer is empty. Okay. Now note that these pointers are there for each of these boxes. So right. Now how do pointers work? So I am giving you just a rough idea. We'll look at it formally a little later, maybe in next lecture. For now, today's lecture we'll only look at uh, sort of an overview of the examples of the lists. Okay. So what do these pointers do? So think of these as containing arrows. Okay. So oh, it's just an arrow. So we don't need this. Sorry. There is only one. I made a small mistake. Sorry about that. Sorry. Yeah. Okay. So currently we have right. So we have the first box, and where will this point? Right. So this compartment will contain an arrow, so to speak. This arrow will point to this one. Is that okay? It contains a pointer which points to the second box. Second one contains an arrow which points to the third box. Third contains an arrow which points to the fourth box. Fourth contains an arrow which points to the fifth box. Fifth one, this is the last box. There is nothing more. This is the end. So there is no pointer here. So now it's the empty pointer. Is this okay? You understand? Now what that arrow is, we'll see later on. But for now, think of that red small compartment as containing an arrow which tells you where it goes. Is that okay?
Yes, sir.
Yeah. Now comes the other version. There are 2 ways in which you can realize an arrow. So this was one. Let's do the same thing. Now do you see you can have forward arrays or backward arrays. It really doesn't make a difference. So the other version is what I was trying to do before. Right. So we have Now the pointers are going from last to this. So this one is going to point to this one. First one cannot point to anything. This is the top element. This is the first element of the array. So empty pointer. Is this clear? Do you understand? Both are the same array, but you can realize them as linked lists in two different ways. One is you keep pointing to the next element, and then the last element will have empty pointer, or you keep pointing to the previous element, and the first element will have empty pointer. Is that okay? Is that clear?
Yes, sir.
Yes, sir.
So small mistake and what I wrote earlier, not two pointers for each box, one pointer for each box, either previous or next. Okay, depending on whether what you choose, there are two ways of doing it. Okay, so this version is what is called a, it's called a singly linked list. सिंगली लिंक लिस्ट मतलब एक बॉक्स से एक पॉइंटर निकलता है. Singly linked list. There is also something that is called a doubly linked list. So again, I'll show it for the array. Doubly linked list. How does that work? That is little bit different. Okay. Now you will have both previous as well as next pointers. Okay. So once again, for the same example, it's the same example, right? Yeah. Spacing थोड़ा गड़बड़ हो गया, but let it be. Not changing. Now each one is going to have a next pointer. Each one is also going to have a previous pointer. Okay, these two pointers are behavior, their behavior is different. Okay? Each one is also going to have a previous pointer. Now do you see the previous pointers are in green, so the first element's previous pointer will be empty, right? Just as we saw before. And the last element's next pointer will be empty, right? Just as we saw before, because there is nothing. And the previous are going to point in the other direction. This one. Is that clear to everyone? This is what is called a doubly linked list. You have both way pointers. Okay, it's a combination of what you saw above. Both of them together. You have two sets of pointers. One set is doing next. The other set is doing previous. Is that okay?
Yes, sir.
Just one more note. When I say it's pointing, see, for instance, this pointer, okay, the fifth to the fifth, it's not pointing to this particular box, or it's pointing to the whole thing. Okay, that's one thing to understand. Similarly here, this pink arrow, the next step, is going to point to the whole object. Okay. Similarly, this previous pointer is pointing to the whole object. Okay, keep that in mind always. Okay, so just that is something that you should remember.
Sir, can you repeat this point once again?
Yeah.
Just one last
So I'm
time.
saying, when you look at this pink arrow, this is a previous pointer, right? From the fifth box to the fourth box. It's not pointing to just the value of the fourth box here. No, it's pointing to the whole object. The fourth box, its pointer, everything. This is like a collection that comes together. Single packet. Okay, this points to the whole thing. Okay,
Okay, sir.
so that you can say its pointer is this, its pointer is this. You'll be able to say that. That's what I mean. We'll look at it more technical way later on, so it will be more clear. When we write pseudocode, it will be more clear. But just understand that the blue cells are the contents, the values that you have. The red or green cells are the pointers that you have, but they cannot be separated from each other. They are always together. Is that okay? It's like one dabba with small partitions. They are not different dabbas. You understand what I mean now?
Yes.
Yeah. It's like your tiffin box with small compartments, not different boxes. All right. So now you have a fair idea what is a singly linked list and what is a doubly linked list, right? And we have seen an example of an array as this thing. Okay. Now let's look at a tree. Binary tree. Okay. What do you think? What do we want? So let me first draw a binary tree here. This is a binary tree. Okay. अब इसका linked list representation कैसा होगा? Can you? So now you have to find an analog. So just take 5 minutes and try to understand between these different vertices, what are the connections, right? Those pointers are defining the connections that you want. Is that right? So what are the connections that you require in defining a binary tree? Just think about that. Somebody wants to try? I mean, we are anyways talking about it informally, no? Pseudocode वगैरह तो नहीं लिखना है फिलहाल. Just give me some idea. Can you tell me every box, how many pointers will it have? Can you tell me? In array, when it was singly linked, it was one pointer per box. Doubly linked, 2 pointers per box. So suppose it's a binary tree, and I tell you I want a singly linked binary tree, singly linked list as a binary tree. How many pointers will be there for each box, for each circle here? How many pointers do we need?
2, right?
2. Why is that?
Because every element has 2 children element.
Okay, very nice, very nice. That is one way. Is there another way? Just like we saw for the array. You can also reverse the directions, no? You get the idea?
Yes, sir.
If you reverse the directions, how many pointers will be there for every box?
It will be 1 only.
It will only be one, because so that's the thing. Every box here has 2 children. So there will be 2 pointers if you are going along children. You are going down. But every box has only one parent. So if you are going up in a singly linked list, then you will need only one pointer. So let's do both. Okay, so let's write both of them. So singly linked. So I'll write in short. Okay, singly LL version of this is what. So let's draw boxes first. And we are going down. So this is the thing. There are 2 boxes. You see, because there are 2 children. And you cannot differentiate between, if you are drawing pointers of a certain kind, it will be there for all cells. Some of them will be empty, some of them will not be empty. That depends later on. Okay. But now how do these point? This points to this one. This points to this one. This points to this one. Right? And what about these bottom pointers?
They'll be empty.
Yeah, they will all be empty. Okay, empty, 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 and so on. Okay. Now the other version, if you have to go up, what will you do? So very similar, right? So now let's try it again. I am trying to go up, so we only need one pointer. Okay, and these will all point. This one points here, this one points here, this one points here. Is that clear, everyone?
Yes, sir.
अभी doubly LL version क्या होगा? I hope you understand now that basically a doubly linked list version is just the combination of both. You understand? You have to take essentially the union of both of these. Is that okay? You understand
Yes,
what I
sir.
mean? So the WLL version is now going to be, I mean, just put both of these together. You have to draw both kinds of boxes, both kinds of pointers. So you have this. You have the bottom, the children pointers, calling them children pointers. And you also have the parent pointers. Okay, they are pointing to the parent, right? So you have the parent pointers. How are they going to point? Parents are going to point upwards. So I need to understand this is the top parent is empty, right? And then the bottom ones are going to be also. And these are all good. So the diagram does not look very good, but I hope you understand. Okay, I hope this is sort of clear now. Is that okay?
Yes, sir.
Now these are special cases. Now you can have linked list. You understand. Now pointers can point whichever way you want. So for instance, you can have something that is not an array or a leaf or a tree, or so something called circular list.
Sir,
Yes.
sir, when we are going in inverse direction, like why we have only one pointer?
Good point. So take any box in a binary tree. How many children will it have? In a binary tree, every vertex. How many children does it have?
Two children. Two
So
children.
you need to point to both of them. So you have two children pointers when you're
Yes.
going down. Take
Yes.
any vertex. How many parents does it have? उसके ऊपर कितने?
Only one.
So it has to point only to one of them. No?
Okay.
See,
Yes, I
it's
got
it
it.
is not that okay. I don't know if you're getting confused. You are not using half number of pointers when you go up. ऐसा नहीं कि when you are pointing to children you use 20 pointers in total, but when you are pointing upwards you are using only 10 pointers. ऐसा नहीं हो रहा है. You see the number of pointers. Look at this. How many total pointers do you have? 1, 2, 3, 4, 5.
6.
And how many pointers do you have here? In the
6.
so that's what I'm saying. You understand? Number of pointers is the same.
Yes.
Direction has been reversed. That's all. Per vertex, the number of pointers has changed because of this difference in children to parent. That's all. You are not using
Yes.
half the number of pointers. You need as many pointers as there were before. Does that clear your confusion?
Yes, sir.
Okay. Okay. So circular list. So somebody wants to guess what a circular list will look like. नाम सुन के क्या लगता है? मुझे 5 बॉक्स का सर्कुलर लिस्ट बनाना है. आप क्या करेंगे बताइए?
एक सर्कल पे 5 बॉक्सेस रखते हैं.
ओके, एक सर्कल पे 5 बॉक्स बना देते हैं. ठीक है. सो 1 2 3 4 चलेगा. 5 बॉक्स बना दिए वैल्यूज. पॉइंटर्स कैसे कैसे बनेंगे?
सब सेम डायरेक्शन में रहेंगे ना.
सेम डायरेक्शन मतलब
मींस बेसिकली 1 बॉक्स टू 2 बॉक्स, की सेकंड का थर्ड वन का फिफ्थ का फर्स्ट
अच्छा.
वन होगा.
हाँ ठीक है. ओके आई अंडरस्टैंड. सो दिस इज अगेन सिंगली लिंक्ड लिस्ट. ठीक है. SLL मैं शॉर्ट छोटा छोटा करते जा रहा हूँ सो दैट यू गेट फेमिलियराइज. SLL सिंगली लिंक्ड लिस्ट. DLL डबली लिंक्ड लिस्ट. ठीक है. हाँ लेकिन पर बॉक्स पहले बताओ पॉइंटर कितने होने चाहिए सिंपली लिंक्ड लिस्ट में? पर बॉक्स कितना पॉइंटर चाहिए?
1.
Only
One.
one.
हाँ सर्कुलर में ओनली वन. यू अंडरस्टैंड? बिकॉज there are no multiple children, right, in some sense. So you only need to point to the next element again. very much similar to an array, except that this is an array where the last element points back to the first element. That's all. You understand what I'm saying? So this will point to the next element. 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 This will be the last element. This will again point to the next element. See, the arrows are going to look like this. Yeah. This will tell me this. This will tell me this. This one will tell me this. ये फिर से इधर जाएगा. That's all. Right? In an array, if I put this empty pointer, this is an array. Do you see? Does not matter how I draw it, but this is an array. This is an SSL of an array. Is that clear to everyone?
Yes, sir.
इसको बस सीधा कर दो ना. 1 2 3 4 5. It's an array. It's exactly an array. But the difference is this one. This additional pointer makes it a circular list. Okay. अभी जल्दी से मुझे DLL कौन बताएगा?
रिवर्स एरोज होगा सबको.
हाँ, रिवर्स भी होंगे, ये भी होंगे. Okay. So we'll have all these. And they point this way. Okay. And then you'll have the diagram थोड़ा खराब हो रहा है, but you have to understand. You'll have the reverse pointing also. This one points to this, points to this, and this one points to this. Okay, everyone? समझ में आ गया?
Yes, sir.
So maybe 2:30. So
can you just wait for a minute? I have to write down this.
so I'm not writing anything more. So I'm stopping here. We'll do this much. You write down and I'm just click on.
Then, sir.
Okay. So this is what it was. And अभी सबके लिए सूडो कोड लिखना है, ठीक है? Now that will get more technical. So that we will do maybe next time. So before we stop, so now I want you, since you have looked at this, now you should go back and read this. Is that okay?
Yes,
You should
sir.
read
Yes.
this now. अभी यहाँ देखो, यहाँ पे थोड़ा डायग्राम ज़्यादा अच्छा है, मैं इतना अच्छा नहीं बना सकता. So try to follow what is given here. Key, when they say key is the value sitting inside. Okay, I hope that is clear. The value inside the main box. And now they have given small pseudocodes. How do you search an element in a linked list? How do you search for the element K in a linked list L? Okay. How do you delete an element? How do you insert an element? Okay. These things are there. Sentinel nahi chahiye apne ko, so that's not there. So as I mentioned, up to this part, read these pseudocodes and try to understand. We will discuss them when we meet next. Okay. Sentinel is not there for us. And ये exercise के पहले the previous exercises you had to try, okay? Before, so you try the previous ones. Stack और queue के लिए जो exercises थे. List वाला अभी मत देखो, list वाला देखेंगे बाद में. But stack and queue exercises you had to see, okay? So these things are not there. हाँ, binary tree यहाँ आते हैं, okay? So this is given for more general tree. Okay, you see this is a doubly linked list representation, DLA. for a binary tree, but some things are missing. For instance, for this vertex there is no 2 children. For this vertex there are no 2 children. There's only one. It's like partial. But now this is more involved. You see, now there are arrows that go aage piche also. Okay? So there are siblings also now. So this is more complicated than just a tree. Okay, so do the linked list part, read it, read the pseudocode, try to understand. Exercise, leave it. Exercise we'll do later. Do the exercise of queue and stack. Try to solve exercise of queue and stack. Okay, and try to read binary tree part. Please. Okay, please try to read binary tree part. We have seen
Yes,
all
sir.
of these today. Binary tree just gets little more complicated with this diagram where children, among children also there is linking. ये मेरा भाई है, ये मेरी बहन है, that kind of connection. Okay, that is also there, and that's it. Okay, just read up to this part. Okay, exercise binary. Okay, please do this. I am still busy this week, so tomorrow we will not meet. Okay, I had written in some post that we will meet tomorrow. Tomorrow we will not meet. कल class नहीं है. Saturday, Sunday दोनों दिन छुट्टी है. Please read this, and we will meet on Monday. If possible, I'll post some 1 or 2 videos. I'm not sure if I'll get time, but if possible, I'll post 1 or 2 videos. अगर मैंने video डाला, have a look at those as well. Okay. So can you do this, all of this before Monday? Please do this. ठीक है. आप इतना नहीं करोगे तो आपके लिए भी तकलीफ है, मेरे लिए भी तकलीफ है. You understand? Please do this much.
Yes, sir.
Okay, sir.
Okay. So yeah. So that's it. Then we'll stop for now. So thank you.